Oh, okay. And now I get the T-shirt. Official cat toy.
Yeah.
Nice. So you are the official cat toy.
I am an official cat toy. I am also furniture.
Gotcha.
You are a warm thing that they can sit on.
I lay
Cats
down
are
and
just
it
jerks.
just sat on me immediately.
What?
I lay down, it just climbed on me and sat on me immediately.
Well,
that's because you're its throne.
No, that's because it's trying to get to your face to smother you to death.
Now, he could have done that many times before when James was taking care of
Wait,
him.
no, now he totally did.
He did try to eat its hand once.
Then again, he was trying to pluck you yesterday.
Yeah, he was. I woke up and he was pulling on my hair. You know how when they put stuff between their paws and bite down and pull up with their head?
Yeah.
I woke up and he was doing that to my hair.
Well, here's one of the things. That's also what they do if they're trying to fluff something before they sleep on it.
So just imagine your hair is a giant bed.
Could be,
Cat bed.
That's pretty.
Cat hat.
I feel like that was the start of a song that nobody knew or cared about.
I don't know, it had potential.
Cat bed, cat hat, da 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 da. Words that have things to do with that.
Of the night, man.
That was terrifying.
It was just
Champion of the sun.
Once again, that was just stealing someone else's bit, Randall.
So why don't you start us off?
James is nearly dead today, so maybe we don't have James start us off.
Yeah, I guess I can. I don't want to do all the talk. Anyway, so we're here, and it's like a lovely sunny and/or wet day, depending on whichever it currently is in the future.
This is being pre-recorded, so even though it doesn't really matter what the weather is outside, for whatever reason, we felt the need to.
It's a real great, like, victory or shame that your team won or lost.
Yes. Also,
Go. Insert team name here.
Red Wings are going to Game 7 in Anaheim.
How about that crazy?
What the fuck's a Red Wing? And what's the fuck's a Game 7?
She's talking
in
hockey.
Anaheim?
It's hockey.
Do we
Are
look
they
Canadian?
playing the Mighty
Yes.
Ducks?
Yes, they are.
They're playing the Mighty Ducks.
Are they going to beat the
Well,
Mighty
here
Ducks?
come the Mighty Ducks.
I friggin' love that show, and you can bite me.
Wait.
You've never seen the Mighty Ducks animated show?
I saw the
That's where
animated
they're
show.
actually
Yeah.
alien ducks that use hockey-like weapons to shoot other aliens.
Fabulous! I love that show. I have all the
Here come
episodes.
the Mighty
Amazing. Can you send them to me?
Maybe.
Okay.
Wait. I thought. This is just like sewer sharks and creepy crawlers.
Yeah, I was
and
at
all
that
those.
time.
Totally is
Creepy
like.
Crawlers was legitimately amazing, and I will cut you if you disagree.
All of these shows were just looking at Teenage Mutant Ninja Turtles and going, "Well, we can do that, right?"
Which
You
is
just
kind
get
of
an
funny
animal.
because
Extreme
now the new Teenage
dinosaurs.
Mutant Turtles movie is totally ripping off the Mighty Ducks cartoon because now they're aliens.
So wait, you're saying it's gone full circle?
Yeah.
The Mighty Ducks cartoon.
Turtles aren't aliens in it.
Yeah, they are.
No, they're not.
Yeah, they are.
No, they're not.
They are.
I will cut you.
Michael Bay said they are. Michael
Bay said they aren't.
Wait.
Michael Bay did not.
Okay. Yeah. That.
This got nerdy really quick.
Let's put it this way. He brought on the original writers, and they made it so that their origin in the movie is almost exactly like they were in the original run of the comics. So
no one
because
knows.
the Krang are aliens, and it's their mutagen, which mutates the turtles,
Yeah, so they're aliens.
No, they're. I
No.
guess.
they have an alien origin.
But
Yeah.
they're
Yeah,
not aliens.
so they're aliens.
You're an alien.
I am
Technically,
actually.
Yes, he is, actually. Oh, this is going to be one of those podcasts.
So this is Paleo After Dark. Kansas doesn't support us. We're going to swear. We are not factual. We don't know what we're talking about.
I think we need to take. Let's just mute James.
Okay.
Hello and welcome to
So
Paleo After Dark.
So we know what we're talking about, but we don't care if we're right. Which is more truthful. Lock up your children, lock up your daughters, lock up your farm animals, etc.
I do feel like with each subsequent podcast, your introductions continue to get more and more sad, to the point where I'm wondering if we are killing you, and I feel really bad about this.
It's slowly killing him. We're like a cancer.
Yeah, well, I mean, yeah. So, today we're talking about stuff.
So I think really our previous conversation about the Mighty Ducks is a great segue into talking about feathers and evidence for it in the fossil
I'm
record.
not entirely convinced that the Mighty Ducks in the cartoon had feathers. I think they just looked like ducks.
So wait, I thought they were alien
I think
ducks.
To be fair,
anthropomorphized alien ducks.
it was probably just collagen fibers.
probably.
Just collagen fibers.
Walks like a duck, talks like a duck. Clearly, it's Howard.
Yeah, obviously it's Howard the Duck, which actually is another example of an anthropomorphized space duck.
But that one had feathers.
Howard the
God, that
Duck
was
just
such
seemed
a bad
kind of
movie.
scary.
Howard the Duck. Well, the movie is especially scary.
Oh, the movie is so bad.
I've never seen it.
Don't
Don't.
really.
Please.
It's George Lucas's greatest work.
Oh God,
We're
it
gonna
is,
have to
isn't it?
cut this part out because he's gonna sue us.
George Lucas, yeah, worked on Howard the Duck.
Is there a part in the movie where he falls in a wood chipper and they just add some plum sauce?
No, but there is duck on duck sex, and then there's duck on human sex.
Yep, and there's also fully displayed duck tits.
But ducks don't.
Yeah,
I think I blocked that part of the movie from my memory because I actually don't remember that.
Yeah,
Although
that's
it's
in the
deep
first
in there
2
somewhere
minutes.
and it does explain a lot.
That could be why, because I think I missed the first 5 minutes.
okay, that's good. So that your sanity was preserved.
That's like opening the Bible, missing the first 100 pages and going, actually, actually makes a bit of sense.
I know people who have legitimately done that.
Yeah, I totally missed, like...
Well, you just have to skip to, after all the begats.
No, they're
Well-
the best parts. They're the bits that remind me of the Silmarillion.
Well, they're also like it's the most
that
sex
book.
in the Bible, right?
Well,
Like think about the density of sex per page.
the Bible's
It's a lot of
accurate.
begatting.
The Bible is a pretty dirty book.
Oh my.
Anyway, so today we're going to be talking about feathers, feathers in the fossil record, and maybe even some about feather evolution. And obviously this is a topic near and dear to my heart as I am actually attempting to do some feather research as part of my dissertation.
Mm-hmm.
So let's start with a little bit of background. For, those of you not in the know, if I recall correctly, the earliest fossil feather ever discovered was actually the Archaeopteryx feather from Solnhofen, Germany.
Yeah,
The
that's
original holotype, which is a disarticulated feather, which has since been removed from being the holotype because you can't say definitely it's from Archaeopteryx.
Yeah.
true. Okay, so
yeah.
originally the holotype specimen for Archaeopteryx was just
the
a
feather.
disarticulated feather.
Yes,
Yeah.
because the feather was found in, let me think back to this, 1856?
Probably.
That sounds about right. And then the Berlin specimen was found a year later.
Okay.
Yeah.
And I believe I have those dates right, but like I said, we don't fact check, so fuck it. The important thing is that the feather was found before Archaeopteryx, the skeleton of Archaeopteryx itself, and it could very well belong to a different a non-Archaeopteryx bird, but it's very clearly a feather. And since then, fossil feathers have been found in Eocene deposits like the Green River Formation. You've got feathers coming out of the Johor group in China. You have isolated feathers from the early Cretaceous of Australia as well, which is actually the only record of avian body fossils in Australia. that
Interesting.
I'm
Cool.
aware of. So, yes, unless something has changed very recently.
It might be that they're looking at the... I know most of, at least the Passeriform birds were meant to have radiated out of Gondwana, specifically from Australia.
No, these are Cretaceous feathers from Australia. You're right, though.
Okay.
They're looking at a Gondwanan origin of...
Did you say... What was your sentence?
There are early Cretaceous...
Yeah, but...
Oh, yeah, so that was my mistake. Sorry, the only Cretaceous record of body fossils from Australia. My mistake.
Okay.
That's better.
So, you can preserve feathers. And there are different ways to preserve feathers. And so this sort of gets back to what we were talking about in the very first podcast when we were talking about taphonomy and preservation. Generally, when you preserve feathers, you preserve carbonized feathers, or mostly carbonized feathers, as Randol can tell us. Sometimes things don't entirely work that way. But generally, so... sorry.
Go.
So generally what happens, you get carbonization, all the volatiles are squeezed out, and you're just left with a carbon film that doesn't have much of anything. Archaeopteryx is different, and as far as I know, it's the only bird that has feathers preserved this way and that they're impressions. And that's the only bird that I know of that actually has true feather impressions preserved and not a carbonized film.
Wasn't there at one point debate as to whether or not the feather impressions were legitimate?
Yes.
Yeah.
When Archaeopteryx was especially when Archaeopteryx was first discovered, people were arguing whether or not somebody had actually gone in and carved them. And this is interesting. And because they were saying that it was too perfect and that some of these features were not correct, because when you look at a feather, and of course normally when I teach about feathers and feather evolutions, I have a nice whiteboard and I can draw on the board and be like, this is the rachis, this is the calamus, these are the barbs and barbules. Can't do that over the internet, so go Google it and look at a picture.
We might be able to just put some simple diagrams up on LinkedIn.
What's a feather?
Yeah, I forgot, the internet.
Yeah, the internet.
It's a thing.
A feather is a specialized keratinous structure that is found, in my opinion, it's found only in birds. Kind of depends on. Again,
I want to say the papers.
It depends on your definition of feather.
It depends on your definition of feather, and it depends on your definition of bird.
Well, if you're just going to
Because then you could
redefine
also
feather to the point where
Yeah.
you're
Well-
right, that's just pointless.
Well, then you have multiple types of feathers.
yeah,
yeah,
I'll
that's-
agree.
That's
Down,
But-
you can't fly with.
But
No.
but feathers have to start somewhere, and assuming that you only define
Yeah.
a feather as the fully formed feather that
No,
you see in
but
birds is
feathers are-
ridiculous.
Well, what about proto feathers?
Yeah, exactly. What about proto feathers? Anyway, let's keep going. You were discussing things that were important. We were getting into discussions way beforehand.
So, the typical definition of a feather is a modified keratinous structure, and they are formed from beta keratin. And you have different types of feathers. You have down feathers, you have contour feathers, and you have flight feathers. And I forgot where I was going with this, so
Tell us about proto feathers.
So protofeathers is the sort of the brainchild of Rick Prum, who sort of sat down and developed this hypothesis on how feathers evolve, and started out with, and it's more complicated this, I'm breaking this down into an oversimplified. So essentially you start out with a filamentous feather, like a down feather, and you get progressively, I don't want to say more complicated, but you go through certain steps, and then you end up with a flight feather, or a contour feather, which is a feather with a rachis, central rachis, and barbs and barbules that branch off. So, but it sort of implies that down is primitive.
Mm-hmm.
Mm-hmm.
And like I said, that's a gross oversimplification, but that's essentially the long and the short of it.
Okay.
Mm-hmm. So you started off with talking about the potential tool marks on Archaeopteryx, which do actually bear close resemblance to some tool marks around the specimens by the preparators.
Right. Oh, that's where I was going with that. Right.
Yes.
And recent studies have actually gone back and looked at these. And it turns out that, so when you look at a bird's wing, they have multiple layers of feathers. You have the big flight feathers, the primaries and secondaries. And then covering those and sort of helping smooth out the airfoil are the primary coverts. And you can have multiple layers of this. The greater primary coverts, the lesser primary coverts, the stuff that nobody really cares about. And what they found with Archaeopteryx is the reason why this looks cross-hatched is because the coverts, the primary coverts, are actually about as long as the primaries.
There was another study in Cambridge, though, that they said that the feathers themselves appear to be of a different cement.
Oh.
Yeah, and no one talks about that one.
It's a suggestion that somebody has just pushed them on at a later point.
I strongly suspect that if I wouldn't be surprised if maybe one of them isn't a forgery. Out of the specimens, because once people knew they were important, I wouldn't be surprised, but it doesn't validate the studies on them as a
we're
whole.
flooded with false fossils all the time.
I can't remember there's an entire book about this false fossil issue. There was this classic example, and I can't remember, it was turn of the century, some paleontologist, where a guy had basically just carved like they looked like perfect animals, like with no bone, just like perfect flesh animal carved in the rock, sent it to this guy, and said, this is great new preservation. We've got the most perfect specimens ever in the fossil record, and the guy just kind of he ended up buying it hook, line, and sinker, and completely ruined his career.
Well, I remember that.
This happens again and again. I mean, there's a guy in Japan who believes he can see miniature people in mica crystals.
Miniature people?
Yeah, like there's miniature like civilizations in mineral.
So like the Twilight Zone episode where they make the really small civilization.
The big one is Piltdown Man.
Yes.
Yeah, and Piltdown Man was a mixture of human bones and animal bones that were dyed to look old, and were done as a joke. The thing was, the guy that was doing the hoax realized that they were taking it really, really seriously, and thought, well, I'll knock this on the head. And he took a cricket bat and sawed it in half and just threw the handle of the cricket bat in there. They'd know it was a joke. The guy excavated and said, "We found the femur."
Yeah.
Because they were so in the mindset of this being an amazing discovery that you could have thrown a teapot in there and they'd have explained it somehow.
It had a second head.
Yeah.
Well, and that's kind of a similar thing with the Archaeoraptor debacle in 2002. You take a dromaeosaur tail and glue it on the body of an ornithoran bird, and you have a missing link. But it's
well, I mean, sometimes those are intentional, sometimes those are accidental. Like you take situations with Brontosaurus.
Brontosaurus.
Right?
Brontosaurus, yes. Yeah. Brontosaurus was an actual mistake.
But that was caused partly because they really wanted to name new species.
So they needed a head.
It was back in the good old days.
They went to a completely other... it was not in the same area. Like, they didn't just accidentally find a head that was associated with it. It was in a similar area, but they found it somewhere else and just assumed it had to be the same thing.
Yep.
So it was still, in some respects, a composite, because it was definitely not the same individual.
Mm-hmm. But, I mean...
Unfortunately, that kind of thing happens all the time, though.
Yeah, I think it tends to come down to either inexperience or excitement. If something seems too good to be true, sometimes it is, but if it seems too good to be true, you can get very easily carried away.
Yeah, you get really excited about this is a brand new find. Oh God, I've got to see what this is.
And that's the thing with like the Archaeoraptor stuff. That was Chinese farmers needing money, so they used to glue things together to sell them. But the people that were buying them got so excited that they didn't check.
Right, because the prettier the fossil, the more money you get from it.
Yeah.
So,
I mean, this is always a potential issue when you're dealing with having to buy specimens, is that often you'll end up with forgeries and fakes.
Oh, this Turkish Euryptid I got that I published, it looked so much like something that's really common in the Baltic that I spent about a month double checking and triple checking that he hadn't just bought it from a website and sent it to me.
Yeah.
It did turn out to be something completely new from Turkey, which was really cool, but I was highly suspicious.
No, understandably.
Yeah. It's an unfortunate thing that you have to be. But and it's not anything new. That's the thing. It's just that technology has gotten really good, and our techniques for preparation have gotten pretty darn good. But that also means, on the downside, that it's easier to be more clever about when you fake things.
Of course. So getting with that basic idea of what feathers are, then there's this recent 2013 paper, which is suggesting sort of it's more of a summary paper of various other studies that have come before, and it's looking at thinking about the basic evolution of feathers through time. And given the close lineage between dinosaurs and birds, and the potential feather or proto-feather fossils or feather-like fossils being found in dinosaurs, they're showing that the way that we're assuming feathers have evolved might be drastically different than what we thought.
Right. This is actually potentially pushing the origin of these proto-feathers, whatever they are, back to basal Archosauria.
Yes.
Which is kind of ridiculous, but I mean, and
well,
I
don't
mean that in terms of like it's bad. I mean, it's just wow, that's
crazy.
But I mean, when you say basal Archosauria, post Cretaceous split.
Yes.
So
Yes.
not that basal.
Yes.
We're looking at non-crocodilomorph archosaurs.
Well, they have. I mean, one of the papers that we looked at, there's that Troodon with some really amazing plumage that they've got running through it. Did you take a look at that one?
No.
Okay.
It
There's
was
Was it
2009.
the pre-Archaeopteryx.
Yeah,
Troodon.
no,
Pericopterus Troodon.
that's Anchiornis.
Yeah, that thing.
Yeah.
That thing is amazing looking, and yeah,
Well, it's another one of those four-winged things.
yeah, so
Yeah.
it's sort of Microraptor-like.
Yeah. Which is really interesting because it shows that this four-winged stage was probably a little more widespread. than
Confuciornithids have the remnants of...
Confucius ornithids and Antiornithines have
Yep.
it. Joe and Jang, I think, did a paper back in 07 maybe, where they actually, or 09 something, where they actually talk about how the hind limb feathers and the hind limb wing is actually probably pretty important because you see it cropping up over and over again in Antiornithines and these things.
that could be a plesiomorphic condition.
Definitely.
In the paper, they also discussed that certain modern birds shows evidence of going towards some degree of four-leggedness, so that there is potentially some.
If you look at things like a lot of birds, and I'm thinking bantams in particular, have ruffles and spurs coming off the hind limbs.
Okay.
Yeah, and there are chickens that have these weird feathered feet, and I mean the feathers go all the way down to on the toes.
Yeah.
It's very bizarre. And this has nothing really to do that, but I always like pointing this out that back in 1914, a guy named William Beebe came up with this Tetrapex origin of flight.
Yeah.
Which I just think is awesome because literally almost 90 years later we find Microraptor guai, which has these four wings.
It's okay. That most of my research is so this German that said this 100 years ago was right.
I just think that is so.
Never
cool.
argue with us.
And I think that's such a cool piece of science and scientific history.
Yeah, this is why the history of ideas is as important as the evidence.
It's kind of like Wegener.
You're always going to go to some degree that the philosophical notion that there is no original idea, nothing is actually brought up in a vacuum, and so you might think, oh, I'm just going back and I'm proving that something someone else said 1 billion years ago was right, but at the same time you're coming at it with a completely different skill set, a completely different mindset about what you're trying to get at.
Oh right, I'm not arguing.
And a completely different way of testing it.
I'm not arguing with that. I just think it's really cool that way back then somebody was like, hey, what if this is what happened? Now,
you shut your damn mouth.
That was probably the reaction that most people had too, but now we're actually finding evidence.
Yeah, it's
and
cool.
I just think that is so cool.
The really interesting thing is that people used to be able to say this stuff without any evidence. And then we find the evidence 90 years later to back up the thing they pulled out of nowhere.
Yep.
Well, I mean,
Science.
I'm sure there was
process.
I'm sure there was evidence of racial senescence in quotes, but
I mean, here's the thing as well.
I wasn't gonna go there.
It didn't used to be so important to cite your sources or publish your data.
that is true, and definitely that's an interesting thing to go back to when you have to look at old publications and you realize you want to see what they're talking about, where they're getting their ideas from, and they don't have to cite.
Yeah.
Yeah.
Major improvements in scientific literature throughout the ages.
Yeah. So the interesting thing in terms of pulling back the origin of feathers is we're not talking about pulling back the origin of flight feathers. Flight feathers are an almost strictly avial and sister group thing.
Yeah.
But
they refer to them usually, at least in this paper, as like barbules or
panaceous feathers. Yeah. But you have basically what are sort of like modified follicles that then have things coming off them, which you have in pterosaurs as well, which they think might be homologous.
Okay, so this is the interesting thing. I had not heard about the pterosaurs thing. Amanda, do you know much about this?
Yeah, well, there's always been debate over whether. Well, haven't you ever heard of the hairy pterosaur debate?
Yeah, where pterosaurs basically bears or
or
flying bears,
giant weird bats, essentially.
Yeah.
And
that's amazing and frightening.
Well, for a long time, people were saying, well, these are muscle fibers, and now they're saying, well, maybe they're
food's here.
Food's
whatever
here.
These things are.
We're taking a break.
Okay, and we're back after a short break for delicious food. So, when we left off, we were talking about pennaceous feathers. And so just as a quick recap, pennaceous feathers are feathers that are the feathers that have the rachis, the central rachis, the barbs, and, usually barbules, which are little branches off the barbs. Anyway, and that's what we were discussing. So, let's pick back up with that. And if I recall correctly, we had been discussing
hairy pterosaurs.
Hairy
pterosaurs, yes.
Which do not have pennaceous feathers.
They have filaments.
But it's funny how many of the animals that you hairy.
How many animals are hairy?
Yeah.
It's just... Okay, well, let us list the hairy animals. Bear.
Flying bears.
Arctodus is scary enough. You don't have to give it wings.
Point.
Oh, come on. Can't you just see it flying around with little tiny bat wings?
Oh, my God.
Jetpack.
Arctodus with a jetpack would be probably the most terrifying thing ever.
Anyway, describe what the animal is that you're talking about.
Arctodus is the short-faced bear.
Giant fucking bear.
Yeah, pretty much take a grizzly bear and add on, another 5 feet or so?
Add on another grizzly bear.
Yeah, it's huge. It's absolutely enormous, and it was a long-legged bear. It was more of a running bear. And it was, most bears are like, we're bears. We're going to be happy. We're going to eat berries and, plants.
Most bears are like, hey,
time.
Human. I haven't had you in a while.
It's a picnic basket.
There's a lot of you.
No,
I'm not going to fuck with you.
Yeah, most bears are like...
This thing is like, hey, human, I'm going to fucking kill all of you.
Yeah, that looks mighty tasty over there. These are really predatory bears. So
you can tell from their diaries exactly what
I was going to say, I'm wondering
Dear diary,
how can we tell
I
that
ate a human today.
How can we tell these bears would fuck everything up?
Dentition and things like that.
Okay. It has nothing to do with looking at their diary changes.
You can tell criminals by their dentition as well. I mean, there's just this way that you can tell if something's going to fuck everything up.
Anyway,
no, James.
Hey, James, open your mouth.
You're referring to their low-sloping brow.
But you can get rid of that with orthodontures, so,
Is what you're saying is they're grumpy because they don't have dentists?
That's exactly what it was.
Okay.
Technically, orthodontist is a different thing than dentist because, that runs in the family. But
I feel like we're getting into semantics at this point. So,
do you know what's more terrifying than a giant bear? The horse that ate meat.
The horse that ate meat?
It's a horse that would run you down and then bite you to death and eat you.
Yeah.
And it just looks at you and it's just breathing heavily, staring, and then it bares its teeth.
That's my horse.
Didn't some...
Velvet Claw.
Didn't some king have it or something?
No, this was an actual horse. I mean, all horses will eat meat if you leave them to it.
Right.
But no, there's this Eocene horse that ate meat.
Yeah.
So it has sharp carnivorous teeth?
Or something like that.
That's awesome.
It's terrifying.
That should be another podcast topic, is really terrifying shit from the fossil record. Just like...
Forest racids.
Yes, forest racids. Anyway, that's another topic for another time.
Shit that we're glad is extinct.
Yes, shit that we're glad is extinct.
Well, I'm not glad these hairy pterodactyls are extinct because I would like to have teriyaki pterodactyl.
Or at the very least to fly on a pterodactyl. Isn't that sort of every 5-year-old's dream?
Yeah.
Really? Pterodactyls are small though. You mean Pteranodon?
Sorry, Pteranodon, yeah.
Quetzalcoatlus. But anyway, so, that's sort of, now people are starting to look back at that and go, well, maybe this is evidence that these filamentous structures actually did evolve very early on in, post-curatarsal archosaur evolution.
And I think this gets into an interesting question about how evolution potentially functions. Like, we can get into if this transformational homology statement, if this assumption that these filamentous structures were a basal point towards the very beginning stages of feathers, then it proposes really interesting idea, or it gives an interesting window into looking at how evolution might operate, and how we could take feathers and create them from something. Well, create, wrong word. That we could have them evolve from something that is completely that is not being used for anything that feathers are typically used for.
But that would make sense at the same time.
Yeah, it would.
I mean, if feathers sprung up and were immediately flight feathers, then there's no way you can tell that from spontaneous anything.
Of course, but I think the interesting thing there is we would typically be looking at feathers, and if you're looking in just like strict natural selection framework, you'd expect there to be some sort of selective pressure just pushing towards flight that eventually you get something that is feather-like. But if you can have various bits where you evolve something for a completely different purpose and then co-opt it later on for a different structure, you can see how very complex systems can actually be derived through really small characteristics that evolve and then work together in tandem for new ways that they previously couldn't work for.
Well, I'll just, well, you guys all know that, well, whatever. But the one thing that I don't like about that 2013 paper is that it doesn't talk about Longisquama.
But Longisquama was probably a dinosaur. Have you seen the more recent reconstructions of it?
Yeah, which is fine. But the thing is that it doesn't talk about the structures that we see on Longisquama. Which is the proto-feathers that you see on Longisquama.
I don't see why they're feathers at all.
That's the only thing that I think that, and you know, I don't care what your stance is on that. I still think it should have been addressed in the paper.
The thing is, it's very easy to hang up on poorly preserved fossils that people make a lot out of because they could be something. But I mean, there's only so much. Yeah, I mean, there's only so much.
The group that went in there got, messily killed. Of course, they were. When was that? That was in 2008 or so. Anyway.
I don't know.
Yeah, we can't go back there.
Yeah, I know, but I mean, it's the same problem with things that were blown up during the Second World War. You know.
Yeah, you get a whole bunch of specimens that are destroyed because of the bombings in the Second World War.
Spinosaurus.
Yeah, needing to get a whole new Spinosaurus.
We have that at KU too. We have the crash collection from the elevator wreck.
Right.
Back when they were moving, so our museum has 7 floors, and back in the day, Vert Paleo was on the 7th floor. And so they decided...
Let's put the heaviest stuff up top.
Yeah, so they decided, well, this isn't working out. We'll move it down to the basement. And, God, I don't remember who was curator and preparator at the time. It was turn of the century. And so they put all this stuff in the elevator. And the curator and the preparator are standing there, and the curator looks at me. The preparator says, I'm not getting in there. And the preparator says, I'm not getting in there either. And so they sent it down unmanned, which was a good thing because the cable snapped.
Yapes.
And so that's why we have the crash collection. It's a jumble of bones just busted all to hell that don't have numbers because it's pieces of stuff.
So do you occasionally just send some poor sap to go there, jigsaw puzzle their way through a few things, or is it just basically crushed to death at this point?
It's pretty much just utterly obliterated.
The funny thing is the only thing they kept using afterwards was the elevator.
Yeah. Oh, God.
Well,
I don't take that elevator anymore.
Which elevator?
The one in the passenger elevator in Dyke Hall.
The one that's always there's always emails about that or the steam system or
something. The building is 140 years old.
That's not that old.
No, I know.
It means it's a building that was shoddily built 140 years ago.
So we're getting a little bit off topic, but
right.
James, you had voiced something about Longisquama and was immediately crushed, so you couldn't say what you wanted to say.
Oh, I was in regards to what I mean. Longisquama, basically it was originally interpreted as basically just a sort of lepidiform archosaur, if I'm remembering correctly.
Yes. That
just had these weird things on it, which are sort of attached directly to the vertebrae.
The skin
coming out of the sides in between the limbs.
Whatever. And it was conned onto because these things look a bit like feathers. I'm not entirely convinced, to be honest, but I'm no expert. But all you have are 4 limbs, skull, and upper vertebrae.
Yeah, the back half of the animal kind of got bitten off.
And
probably.
People have looked at this. The skull's been restudied, and it's probably they think it's probably a saurischian of some form, perhaps.
Okay.
But they have also found isolated proto-feather-looking things.
But they're isolated. You can't actually say where they're coming from.
But here's the thing.
There's something with proto-feathers in the area.
Right, exactly. Yes. And they have people have looked at that and gone, wow, yeah, these look a lot like developing feathers.
But here's the main thing, right? If they are, and if we're putting the origin for proto-feather type things down, they probably are.
Longisquama is Triassic, by the way.
They're not for flight. People that reconstruct them as flying piss me off because there is no way they could support its weight. even in a gliding system. There's just no way. So they're not for flying.
Well, and again, getting to this notion that you don't have to evolve feathers specifically for flight. The first feathers that ever appear, you shouldn't expect that they're immediately being used for flight.
Right.
Yeah.
Because there's in Primeval, they have a pet longish squama, and it just zips around the sodding room like it's a flying bloody
I was wondering
squirrel.
when you were going to bring that up.
What the fuck is Primeval?
It's this horrible TV show that basically, when they realised that Walking with Dinosaurs wasn't going to make enough money, the company was bought by ITV, which is basically the non-government supported alternative TV channel.
Oh, great.
Take Walking with Dinosaurs, cross that with Doctor Who, I guess.
No, shitty new Doctor Who, not good Doctor Who.
Well, I guess that was
so 80s Doctor Who.
No. New Doctor Who, rubbish Doctor Who, not good.
Old Doctor Who.
So what? At what point do you consider Doctor Who rubbish Doctor Who?
I don't mind most of them, but David Tennant is not David Tennant. Sorry, the fat.
Christopher Eccleston.
Yeah, it's Mr. Potato Head.
Mr. Potato Head.
Wait, now, which number Doctor?
That's 9.
Okay, so it is Christopher Eccleston.
Yeah, Mr. Potato Head is a fucking northerner that just shouts over everything.
Okay.
With a giant nose.
The giant nose.
It looks like Mr. Potato Head.
Okay. So
and that's as much emotion as we'll see out of James today.
So that is the cutoff point.
There are bits that, let's face it, Doctor Who was never always good, but it was always interesting. And the main thing is that they used to be able to get away with 6 to 8 parts, and that let them have a good story. Everything's rushed now. That's not in trouble. But so this longest squama thing, and it's okay. So basically, Primeval's terrible.
Even I will admit it's total bullshit.
And I mean, first of all, the only reason it's there is so that one of the girls from S Club 7 plays the woman that's looking after it, and because it needs a warm environment, it's an excuse for her to turn the thermostat up and walk around in her underwear, in every scene in her apartment.
Okay, so this is for the kids then. This is education
for the
kids.
And the best thing is
that's a bad thing.
That keeps getting better and better.
For the kids.
For the kids.
The best thing as well is that the people that are studying these things aren't paleontologists; they're evolutionary biologists, because evolutionary biology is sexy and paleontologists are boring.
No, I thought the main guy was...
he's an evolutionary biologist.
So they don't even go like the Jurassic Park thing? Because, in the early 90s, man, being a paleontologist, you get to be
you
grand.
Want one of these things?
Yeah.
Smell.
Oh.
I have no idea what he's talking about.
He's talking about the kid.
Oh, okay, right, yeah.
I'm really sad that it took me 0.2 seconds to get that.
That apparently got re-released. I haven't.
Yeah.
He saw it in 3D, that's why.
See, I was just a nerd and watched it because Dad sent me the DVD.
See, I just remember Clever Girl, because why wouldn't you remember Clever Girl?
See, what bums me out about that, though, is that they totally butchered Gennaro because he was totally awesome in the book.
Well, that's because they combined him with another character.
Yeah, they combined him with the
tour guide.
The publisher.
The
publisher.
PR guy.
Publicist.
The publicist. Here's the thing. The film bears no relation at all to the book.
No, it really doesn't.
In any way. Muldoon is a drunk Scotsman who spends the entire time hiding in a pipe firing rockets at raptors.
In the book, aren't the raptors also Deinonychus? They're not velociraptors.
No. They're turkey-sized.
They're actual size.
They're small.
They're small.
But the thing is, they can still fucking disembowel you.
Well, yeah.
Well, if you look at the actual claw on Velociraptor, the damn thing is still 6 inches long.
Henry Wu is still on the island, and
he dies horribly.
Hammond is an asshole.
Yes.
He also dies.
Spoilers. Michael Crichton actually...
It's a 20-year-old book.
Yeah, the book came out in 93.
Yeah. Michael Crichton actually covered as well the problem with advancing science. So he talked to Horner and Backer, who, despite the fact they're a bit crazy, were actually quite on the ball in the early 90s and a bit ahead of the curve. And they said, irrespective of whatever you think, dinosaurs are more avian in aspect than reptilian in terms of life habits and being active predators.
They're not slow-moving, stupid, sluggish things.
So what he did was he wrote dinosaurs to be reptilian-looking but definitely active, and then had Wu explain that. So when we first hatched them, they looked weird. So we engineered them to be more reptilian, so people would get to see what they expected.
So he even goes so far as to say in the book, like, we don't have it right, but we engineered them to make it look like what we want it to be.
Yeah.
So we turned them into dragons.
Yeah.
Okay. That's interesting, because this has been something... So most of the feather stuff is all coming out of specimens that are coming out of China, right?
Yeah, the Johul group, yeah.
Which is an interesting element to this, because either China represents a unique, like, evolutionary unit, or it represents a unique taphonomic window.
It's the only swamp in the entire planet during the Jurassic.
So
Cretaceous.
I was saying, because
originally they said it was Jurassic, but it's Cretaceous.
Because that is the interesting question: is to whether or not this is taphonomic or evolutionarily.
It could be a concept of both. There have been a lot of discussion over whether the Johul biota is a cradle or a refugia. It's kind of.
We get therizinosaurs like outside of China, though. I mean,
the first one known was Segnosaurus. That's North American.
Yeah.
Right, but
which didn't know what it was.
What we're talking about is things like, so you get these really bizarre primitive dromaeosaurs like Microraptor.
Yeah.
But at the same time, you've got full-fledged ornithorhyn birds in Yanornis.
Mm-hmm.
Yeah.
Yep. But I mean, your own work's shown that birds are globally spread by that point.
Right.
They're just not being preserved.
Well, here's the thing. You get part of this is just straight up bias. Birds do not preserve well.
Understandably.
They're very, very fragile. The bones are very thin. They're pneumatic, which means that the air pockets have impinged on the long bones. So you actually have the respiratory system in the bones in birds. And they break apart easily. And a lot of the environments that they live in, birds fly. So they're not really likely to die in places where you be like, hey, we're going to get a bird preserved here. No, it's going to die in the middle of a field, or it's going to, if you get real lucky, it'll die and fall in a river somewhere. And so you'll get like one bone, which is what we get a lot in the Hell Creek Formation, which is this big late Cretaceous deposit in North America. And it's a mostly fluvial deposit, so lots of river deposits. Sometimes, if you're really lucky, like Robert De Palma, you get an Oxbow Lake.
Okay.
And you get some great stuff in an Oxbow Lake. But that's a really low chance of finding one of those. They're temporally very, very short-lived, and they're spatially very restricted.
Yeah. Well, you need to catch it as it's drying up as well, because you need the anoxia in order to get the preservation.
Exactly. Yeah. So China is extremely unique, and there's still argument over how many lake basins there were, whether we're dealing with one big lake basin or multiple small lake basins. They're starting to sort of agree on how they formed. They're thinking it's a graben, sort of like a drop-down basin environment, because we're getting a lot of tectonics. I had to do all this for my comps. We're getting a lot of tectonic activity in the early Cretaceous. Bless you. Yeah. There, I called it. Bless you. So that's the other reason why we get a lot of ash layers in the Johul group.
Okay.
That's how we have such really well-constrained argon-argon age dating for this. So it's entirely possible that we're dealing with something of a refugio, so we're getting all of this primitive morphology still hanging around, combined with this really, really good taphonomic window.
One thing I would say about the concept of refugia...
It's not a perfect concept, but...
I don't buy into it as much as... I think all your basically
so
the concept of a
really quick. What do you mean by refugia?
So basically, the idea of a refugia is that it's basically it's like the Great Valley in Land Before Time.
The Great Valley in Land Before Time is a great choice.
So the Great Valley in Land Before Time is in China.
And for everyone who was not alive in the 80s, the Great Valley is the place that all the dinosaurs are going to when things go really, really bad, so that they can survive.
Also, go watch it because it's a really good movie.
But don't watch 2 to 14.
No,
because the other ones weren't involved with Don Bluth. Anyway, continue.
Yes.
The problem with refugia concepts.
So, what I strongly suspect is because these things obviously have a low abundance, they're still everywhere, but you need special preservation to get them preserved, because otherwise there's so few that they're just going to be
I mean, this is a potential situation that you see with so many of the Cambrian stuff. Like, your Anomalocaris, you get that kind of stuff that continues on into the Devonian, but it just requires very specific taphonomic windows to be able to preserve it.
The only reason that I'm not totally buying what you're saying, and I understand, and it's a good argument, but we do get Enantiornithians and things like that in North America. But we don't get these really wonky... we don't get Confucius ornithids. We don't get, the long-tailed birds. We don't get anything like that.
Well,
so, I mean,
Confucius ornithids, let's face it, aren't primitive. They're very specifically derived.
Very specifically
so
derived.
They could just be limited geographically to China because that's where they evolved. They never spread and then they went extinct.
They are more basal than ornithorans.
But there's a really long, what we term ghost lineage.
Yeah, there's
they diverged from.
I want to say we get Confucius ornithus at what point?
127 million years ago.
So Cretaceous?
Early Cretaceous. I'm trying to think of when Confucius ornithus was around, and I think it was a little bit earlier than that.
You have a massive rifting from North America and China. All that kind of stuff is happening after you get the supercontinent of Pangaea breaking up.
And to put the age of that into perspective, some people still flip over whether Confucius ornithids came before or after the Archaeopteryx type thing.
That is true.
Whether or not they're more or less derived.
Yeah, and Archaeopteryx is Jurassic.
Before or after is kind of nebulous terms because you're talking in that way, like temporally, and that's not really the case. We're talking about evolutionary descent.
Evolutionarily,
Yeah, so if they flip it and Archaeopteryx is slightly more derived, then you're looking at about 50 million years of Confucius ornithids that we're not getting.
Which is entirely possible because Confucius ornithids... one of my dissertation chapters is on Confucius ornis, and the morphology on these guys is just utterly bizarre. They have this enormous delta pectoral crest, so your humerus is the upper arm bone, and you have this big
what's it connected to?
No, that's the funny bone, whatever. Anyway,
shin bone's connected to the
So on your humerus you have a ridge of bone where it's for muscle attachment, and it's usually your deltoids. And there's other muscles that attach there, but I won't go into it.
Where your cranial crest would be as you say this.
James, what is a cranial crest?
It's where in everything by humans, because we've got really weak jaws, there's this ridge on the skull where all the jawbone musculature attaches to.
Actually, to get that kind of motion, It's for the snapping of your jaw.
The fact now that it inserts near the ear is why whenever your ears pop, you often do it by having to swallow and tensing the jaw muscles.
Yep. But Confucius ornithids have this enormous delta pectoral crest with a hole in the middle. And nothing else has that. I mean, Johilornis, which is another primitive long-tailed bird, has something that's kind of similar, but the entire shape of the bone is different. The positioning of the hole is different. It's not always a complete hole. Sometimes it's a partial, it's partially open on one end.
Could that be
I think it's convergence. I don't think they're...
Okay, well, I wonder if it's varying within the species, is it ontogenetic? Is it opening up or closing as it gets older?
For Johilornis?
Yeah.
Nobody's done that. There are only a handful of Johilornis specimens.
It's difficult with most vertebrates to have enough specimens to actually do those kind of studies.
But with
difficult with most
Confucius
invertebrates other than trilobites.
Although the problem is with Confucius ornis is that I'm not aware of any juvenile Confucius ornis specimens. Every specimen that has been found that I know of has been an adult.
Well, how many specimens have been found, though?
Thousands.
They've got quite a lot.
Literally thousands. There is a museum in China, the Tianyu Museum in Shandong Province. That museum has over 1,000 Confucius ornis specimens.
And they believe they can separate them into males and females, which, based on I'm suspicious, but then based on the marrow data.
Yes, based on the marrow. It's a type of bone that you get in birds when
if you core it, only females that are gravid or whatever the word is.
Oh right, this is something that they discussed in the 2013 paper. Yeah, the sexual dimorphism due to coring the marrow of the bones.
There's a certain type of bone, and they found it in one of the Confucius ornithids, the Confucius ornis specimens that doesn't have the tail feathers.
Yeah.
So Confucius ornis is characterized by some specimens have these big, long, wonky-looking tail feathers. And some of them don't.
Think widow birds in probable function, even though I showed these to Amanda, and then she's like...
Think standard wing nightjars, because the widow birds...
Why not?
Because what it is this long portion that doesn't have barbs, and then there's barbs at the end. Which is really weird, and it's nothing that we see in modern
Birds of Paradise.
Today. This is getting into that chapter that I don't want to talk about.
Okay.
But it's really complicated, and it's very bizarre, and people are still arguing over exactly what the morphology is. And I can't talk about that right now. But, I'm not talking. I forgot where I was going with this. But, so people have been using it as sexual dimorphism, and it's weird. I mean...
The cool thing is you still get size clusters, even though you can tell
clusters.
That the females are adults.
You get size clusters, and James and I were looking at this paper, I don't remember what paper it was. It was a 2009, 2010 paper.
Yeah.
And you could see 4 discrete clusters of mixes where they had ones with and without tail feathers. And they were saying it was a growth line.
Okay.
But the males reach sexual maturity.
And also, these aren't arthropods. They're vertebrates. You don't get clusters of growth.
No, you would not expect some sort of unless
it's 4 different species.
Yeah, it's that, or it had really constrained, like they could breed for 4 days out of a year, and then every year you got like stepwise clusters like that. That is really...
And here's the thing.
Weird. I don't think that's...
Other studies of sectioning the bone have shown that Confucius ornithids are endothermic. So they're warm-blooded.
Okay.
Now, they derived this separately, because a lot of enantiornithines are not. They're poikilothermic. They're cold-blooded. So that's another really weird thing. They just totally separately derived endothermy, and we're like, woohoo! But that is...
To be fair, immediately once you drive endothermy, you're like,
it's that hot Latin blood.
I got energy. I have to eat a lot, but warm-blooded.
But
to be fair, they were just running around the trees, eating everything they could find.
Pretty much.
Hey, you see that thing in the tree? I'm going to eat it.
But that just further drives home that you don't get these isolated growth stages in endothermic animals.
If you'd seen my talk that I gave on the Euryptids, the first thing I said was like, this is why arthropods are excellent. We can do this. You can't do that if it's got a backbone, because they just grow.
Fuck you. Vertebrates are great.
No, they're great, but they're frustrating.
Yeah, they are.
But I think it's just endothermy and ectothermy, like those kind of situations where we have this characteristic that seems potentially, because it does define mammals, like it should be something really important, but if in the origin of birds it just seems to be coming up independently and multiple times, that's an interesting factor.
It is really interesting, and...
Sharks do it too, though.
You're right.
So do tuna. So do a number of other things. It's linked to... Well, okay. It's linked, we don't know which one comes first, it probably changes each time, to a highly active, often predatory lifestyle.
I mean, there is some potential necessity. Although
birds,
the question is whether or not the necessity forces...
Probably nocturnal hunting, because that's always
and
very important.
Yeah.
The difficulty with this kind of correlation is you run the risk of either saying that the necessity the necessity for predation, forces the hand towards warm-blooded, or the warm-bloodedness opens up the opportunity.
Yeah.
You're intractable.
We know there's a correlation, but you can never say for sure why.
And also keep in mind, it's really energetically, when you're eating plants, it's incredibly energetically poor. Every vertebrate that is endothermic and is also a herbivore has modified, either has a really bizarre feeding strategy like geese. Geese are herbivores and they don't have any specialized gut, but they just eat and eat and eat and eat and eat constantly, and they'll get some of the nutrition, but they poop out most of it. But when you're dealing with something like a hoatzin, which is the weirdest fucking bird, by the way.
They're amazing.
They are the only foregut ferment. They're the only fermenters in birds. They actually have their crop have been modified into a fermentation chamber.
They suspect, although they've got no proof, that the same thing is true in therizinosaurs. That's where you've got the greatly distended bellies and the distended sternum in therizinosaurs.
Interesting.
Oh.
But what's really interesting about that is that you get a reduced keel in hoatzins, and it makes them really shitty flyers. If you look at mammals, you see the same thing. Herbivorous mammals are either hindgut or foregut fermenters. I'm not including the proboscideans and things like that. They're a little bit different. but horses, foregut fermenters. Bovids, so cows and bison, things like that. No, you're right, foregut. Sorry, hindgut. Horses are hindgut fermenters. Because
hindguts don't chew the cud.
Yeah,
foreguts do.
Foregut is more...
Because they just throw it back up and then they eat it and they throw it back up and they
eat it. Foregut is more efficient. Hindgut is less efficient. And so parasitactyls like horses and...
So it's like front wheel and rear wheel drive.
Very, very similar. So anything that eats plants essentially has to have this specialized metabolic system because we cannot break down cellulose.
Yeah.
Vertebrates cannot do that. And so these animals have these specialized endosymbiotic bacteria that break it down for them. So it's not a far stretch to say that if you are going to be endothermic, if you're primitively endothermic, you pretty much have to have a high protein diet.
Or it's, omnivory
omnivory at worst, essentially.
Or you very much tied, you're always very much tied to food sources, but you'll be much more... Okay, give me a second. Endothermic herbivores are very static until they have to run away from a predator.
Yes.
The activity is basically in short bursts, whereas predators will be much more active by and large because they actively have to seek food more.
Although, to be fair, like your actual cold-blooded predators, like you got your crocodile, for the vast majority of your time, you just sit and you wait and you watch. And then there's a brief moment of activity, but you have the upper hand. You drag it down to the bottom of the ocean, not the ocean, the river or the lake or whatever, and you just let it drown.
Saltwater crocodiles.
Yeah. You just let it drown.
Yeah, and it's a very passive hunting style versus something like an insectivorous shrew, which is constantly moving around and foraging. Because it literally has to eat some ridiculous amount times its body weight a day, or it starves to death.
Yeah, and this is the thing. Endothermy, you bleed out so much more heat.
Yeah.
And you run so much hotter, and you use up so much more in terms of energy. You need to be able to eat every day or every week, because a crocodile can go for months.
Yeah.
Yep.
Yeah.
Yep.
Sit there, not caring, watching the day go by.
The really fun thing is when we're in the Everglades. Sometimes you'd see one, and it'd see you, and you'd slightly turn, and it would submerge. It's like, the fuck is hunting me now?
I want to go back to the Everglades.
That was one of my favourite places. Not Florida, but the Everglades was amazing.
Yeah.
When they kill those giant fucking snakes.
Yeah. my favorite bird ever lives in the Everglades. It's the anhinga.
Oh,
getting eaten by those giant
That's
fucking
because it's
snakes.
a Hesperornis.
It kind of is a Hesperornis, except it eats differently because it spears the fish. Hesperornis had teeth, so it would just grab them.
And hingas are amazing. And
Hingas
the
are
waters
so
can be so clear, you get to see them swimming around, and there'll be parrotfish have come up, and they'll be like having to go at parrotfish, and then you'd see gar as well, and then alligators, and then snapping turtles, and the hinga will be like, I don't care, I'm an anhinga. And then it'll jump up on a rock and spread its wings and just dry, and be like, I don't care, I'm an anhinga.
Yeah, anhingas don't have oil in their feathers, so most birds have an oil gland on the tail. Anhingas don't have that. So it helps them not be buoyant, so they sink. But then when they get out of the water, they can't fly until they dry out their wing feathers, so they sit there and just look really stupid and just be like, yeah.
That's where you get the pictures where they just look like a drowned rat,
yes,
but they're a bird.
Exactly.
Am I wrong? They're not divers. Are they cormorants?
They are also called snake birds. They are...
I'm just wondering, because cormorants
they're in their
dry
own group.
like that. Cormorants look a lot like them. They're seabirds. Cormorants and shags.
Cormorants still have oil. They have less oil, though.
Yeah, they're just shitty.
Yeah.
But they're not, the anhingas aren't, even though the similarities there, they're not related to loons, even though the feet are pushed back a bit as well. But
yeah, they are... They might be more closely related to cormorants. I'd have to double check but the phylogeny has changed so many times with all the new molecular data.
However accurate all of that is, whatever.
That's a whole other conversation.
It'll always change.
Yeah.
Well, it will always change because we're never going to know the truth, certainly, but we're going to approximate it, hopefully better each time.
In terms of
like
morphology...
we are with all these feathers.
Like we are with all these feathers. So getting onto that kind of stuff, do we want to talk a little bit about the potential melanosomes? I think that was an interesting paper.
Yeah, that's a worthwhile discussion to have, especially given a lot of the... papers that have been coming out based on fossil colour of late and the discussions surrounding that. Which
I was very the structures I thought were interesting, but I was really perplexed when they went to the point of actually being able to tell what color the animal was.
I'm
primarily
either
the red, yellow, or the black, gray.
Yeah,
that's based on orientation.
Yeah,
I'm
that is
actually
based on orientation.
vaguely. It's really interesting, and I'd love it if it were, the actual thing. But I was talking to a colleague of ours who has been looking into this, and he does a lot of stuff with like biofilms and stuff like that. And so when he first saw it, he thought, "Hey, these are bacteria biofilm." But
they addressed that in the paper.
Yeah, that's the thing. But he went back and looked at it, and they are actually concave structures.
Okay. Well, that's what they say.
Yeah.
Well, no, this is what they say inside.
It's in the paper.
What they say is that basically you've got some where they're preserved, but others it's where they have weathered away, and it's the indentation, because these are molds, they're not the actual fossil.
That's interesting.
This is the thing. I'm certain these aren't bacteria. You can tell.
No, that they're not bacteria.
Yeah, and they're not biofilms. They are some integral structure to the feather. And to be fair, I mean, I don't know if you guys saw, there was an interesting little spat in science between two colleagues at the University of Bristol about this.
No, I did not.
Okay, they agree they're melanosomes. One of them says that you can use them exactly to work out the colour based on size, shape, and orientation. The other one says you ignore taphonomy. These things have been baked, they've weathered, they're smaller, and you can tell they're melanosomes, but you can't tell the colour from them.
And that's actually a good point, because when they reconstructed Microraptor using melanosomes, the whole thing was black. I mean, a melanosome is essentially a pigment molecule inside a feather.
Yeah.
Be interesting. Sorry.
No, but
that you get banding, and they're not there. First of all, they're not there on the
areas that would not have color.
Yeah, and they're not there on the pale bits in the fossil where obviously there is no color preserved either.
Yes.
Yeah.
So I'm fairly certain that these are melanosomes or precursors to melanosomes. I am not entirely convinced you can take it as far as people take it, at least in the Cretaceous stuff.
Yeah, because I mean, like you said, we get color banding in Cretaceous birds. In the fossils, like in the TNU, you get birds with that.
Well, I think the interesting thing also about this paper is that it looks on specifically Confuciusornis stuff.
Yeah.
Not pronounced that word to save my life, apparently. But it also looks on certain non-avian dinosaurs, and suggests that it's showing the same banding patterns that you're seeing in the Confuciusornis stuff.
Or the fact that these things have melanosomes, so they're not the muscle fibers that Lingam Soliar keeps banging on about.
That was really interesting. That there was there's been suggested they're muscle fibers, and it's like 5 publications. I'm like, okay, and I look in every single publication.
Do you know what that comes
from? Him only lead author.
Do you know what that comes from? He works on ichthyosaurs. Ichthyosaurs basically explode when they rot, and you get tendrils of muscle fiber coming out of them.
That is disgusting and amazing.
And has seen this, and then said, this is exactly the same thing in these things, but they're completely different taphonomic regimes. And I hate to say it, ichthyosaurs are bundles of tendon and muscle, which other animals aren't. It's a different thing entirely.
Break the bundle, and what do you think happens?
So you're just suggesting, Randall, that an ichthyosaur is a fleshy pinata?
Sure.
But
tasty.
Ew.
Gas-filled.
It's no longer sounding all that awesome now that it's a gas-filled pinata.
Well, they were bloated.
No, I'll agree with you. No, they were a gas-filled pinata.
How do you think they exploded?
Yeah,
exactly.
So here's the interesting thing in what they say the colours were. They say Archaeopteryx was almost entirely black. They say Confuciusornis was iridescent, like a magpie.
And they say Microraptor was entirely black.
Yeah.
Iridescence, like a magpie.
Which one's the one with the white spots? That's Microraptor's got white spots, right?
Microraptor, they reconstructed it as entirely black with iridescence.
There was one which supposedly has white spots on it as well. I can't remember which one that is. But here's the thing. I mean, taphonomy is going to affect things. If you can do experiments and understand the taphonomic pathway and see what happens and this is what the person that was criticizing the original studies was doing. They are baking these things and seeing what happens to them and saying, okay, so this correlates with this, and basically instead of everything being black, things are reds and browns, because guess what? In nature, most things are reds and browns.
That is true. Yep. And that was at least one interesting thing about this, is that they did reconstruct this thing just as brown, which admittedly a lot of birds kind of are brown.
The problem... Yeah. Well, female birds are.
Yes, certainly.
But male birds aren't, and there's a reason for that. Birds actually have excellent color vision.
They can see 12 colours. They see way into the UV range.
Yes, they see way into the UV
Bear in
range.
mind, we see 3. Yeah. We see 3 combinations thereof.
And
they can see like 6 times that. We have no idea what those things look like.
Yeah.
And
does the color red look the same to you as it does to me, man? Anyway.
So, yeah, I mean, now color banding is something completely different because you can have things that look very pale to us.
Yes.
But in the UV range, they go bananas.
It's like blue tits.
Yes.
Blue tits are blue and whatnot. Blue tits are basically like little rainbow birds if you're another blue tit.
Interesting.
Yeah. And budgies will have, even for parakeets, I mean, they have little white spots on their neck. You hit that with UV and it becomes incandescent.
And here's the interesting thing. Butterflies, especially a lot of the white ones, they look white, but they're super ornate detailed, which is designed to try and which they think might correlate to trying to confuse birds. Like, you'll have patches which look like giant eyes that you can only see under UV, because the only thing that will see that are other birds.
Interesting.
Or are birds, rather.
And, I mean, you see this across modern birds. I mean, it's just absolutely ridiculous. Things like birds of paradise, they look crazy even to us. They've got these vibrant, iridescent patches. You hit it with UV and it's even crazier.
Actually, that's the thought. Hang on. You know, people put up these little silhouettes to try to stop birds hitting windows. If you just got a UV spray and just went and crossed it, they would know something's there.
That's a really good idea, and it wouldn't disrupt.
Copyright.
Copyright. Good call, Randall.
But yeah, I actually the argument is a very sound one that we're probably not really able to say what color these actually are because of Teflon.
But getting into this notion that birds see things way more complicated, and also that we're getting these melanosomes even in things closely related to birds, I think the interesting element that the paper goes into as a possibility is that if we are looking at these things as original feathers, either like prototypes for the proto-feathers or just some other structure that would eventually become a proto-feather, that potentially these things could have been just as useful for sexual selection or for some sort of recognition of identity in species, some sort of species mate recognition system in non-avians as well. So that could be a more primitive, uses is, again, a very subjective term. In biology, things aren't really function.
Okay, here's the thing with that. I am sympathetic to it, but there are two things. I mean, we know that mate recognition is a big thing in birds, mostly passeriforms, because let's face it, a lot of the gulls look exactly like each other, but they communicate mostly by call.
Yes.
Yeah. I mean, gulls and penguins can recognize life partners based purely on call, even if they haven't met them for 2 years.
Right. There are flycatchers that look practically identical. Like, even down when you have them in the hand, you cannot tell them apart. But you put them on, you put them in a cage and they sing, and the song is radically different between the two.
Yeah. Huh. So now, and that is probably a very derived function for passeriforms, they are the most common, right?
Yes.
But they're the youngest. Like, they're a really recent explosion of diversity linked to perching and song.
But you see it in non-passeriforms too.
Yeah. As I say,
penguins,
individuals,
gulls.
Not just species, individuals recognize each other based on their call.
Yes.
The thing is, display in some form is very important for a lot of animals, but it's the same thing as ritual in archaeology.
Yes.
We fall back on it as an explanation because if it doesn't make sense, it's probably sexually selected or sexual dimorphic.
The old mainstay, if it doesn't make sense in biology, it's sex.
Yeah.
If it doesn't make sense in
Or
archaeology,
religion.
It's religion.
Yeah.
So while that could very well be the case, and I think in at least some cases, almost certainly the case, proving it is a completely different thing entirely.
I totally agree, but it is at least interesting if you've got these situations where birds can see these very complex color patterns, and we are seeing in things closely related to birds the potential to be displaying these complex color patterns. It's just an interesting correlation.
And we have bona fide dimorphism in Confucius ornis.
Yes, we do.
Which is
Linked to plumage differentiation in the tail.
Yep.
Yeah. And there's a friend of mine, she's just finished her PhD at Cambridge. She was looking at hadrosaurs, so duck-billed dinosaurs, stuff like that. They are probably horribly oversplit because the bodies of everything, the bodies of these things never changes. The skull changes quite a lot, and they get these different crests.
Yeah.
the crests are probably dimorphic.
So they're suggesting that your Parasaurolophus and your others,
like things like Corythosaurus and the non, like you'll get Corythosaurus, it's always there when another hadrosaur doesn't have a crest, and it's like these might actually
probably
be
male female groups.
Very interesting.
Yeah.
What is it? Edmontosaurus doesn't have a crest.
Yeah, stuff like that.
Yeah.
That's a difficult situation to. You'd need to be able to get ontogenies of these things to see if they differentiate at a certain point.
That was the exact, I think, point of the thesis, because they've got a couple of. The trouble is the ones where you get large herds, they're like iguanodontids. Iguanodontids don't have crests.
Yeah.
But she did a lot of work on ontogeny of crocodiles in the hope of, like, so if you get your 6 skeletons and you don't have a full growth range, but if you know how archosaurs tend to grow, you can start to draw broad conclusions.
Okay.
And sadly, she's never got around to publishing anything yet. But it's interesting stuff.
Yeah, it's an interesting avenue of research to look into.
Yeah.
I mean, there's the whole notion of ontogeny through dinosaurs as well has come up a lot. With what was that recent thing where the Triceratops is
Triceratops Torosaurus. Well, this is Horner shitting on everyone.
Okay, well,
Nanotyrannus is
like
sometimes
physically, or
well, I mean, Nanotyrannus is either, depending on who you talk to, a valid genus of dwarf tyrannosaur, or it's just a juvenile tyrannosaur, or perhaps an Albertosaurus. The same thing for your Triceratops Torosaurus. The fascinating thing about that is the media can't understand the fact that even though Triceratops would be the juvenile, that it would still have priority.
Yeah, because it's an older name.
Because they think that the adult should be the one that keeps the name.
Yeah, well, I mean, the ICZ is its own thing.
Yeah. And there are things like, there was a Dracorex hogswartia, which was this pachycephalosaur that was named after the Harry Potter stuff.
Wait, named after Harry Potter stuff?
Dracorex, which is Dragon King, and then Hogswartia was the species name.
Hogswartia.
And that was named, and then within a year, probably a juvenile Stigmaloch, which is another pachycephalosaur from the same locality. A lot of the Morrison Formation stuff, and the Morrison Formation counts for about 60% of all Jurassic dinosaurs. Some of the sauropods, we might be down from 15 species to 5, when they start taking ontogeny into account.
Oh, the Morrison's fun because it's another one of those big fluvial deposits.
Yeah. Of course.
So you're getting there. I mean, the famous Cope and Marsh quarries were just literal bone beds where you just had the current dumping shit in a big pile.
Again, literally.
Somebody would come along and throw a stick of dynamite at you.
Sometimes literally.
Yeah, okay. And also they would dynamite each other's quarries.
Yeah.
Or their own quarries.
And once we're done with it, slash and burn.
Yeah, literal total war between these two groups. It was Wild West crap back in the day. It was
the Wild West.
It was the Wild West.
Yeah, I'm going to agree with Randall on that one.
But it was totally crazy awesome. And I wouldn't have been able to do anything with it because I am female. It was the 1800s.
Mary Anning.
To cook.
Mary Anning was currently being ripped off by wealthy old white dudes at that point in time.
Amanda, you could have been ripped off.
That is not comforting, James.
Yeah.
It's okay. I'd be good.
He'd tell you to go back to the chow wagon and make him a sandwich.
No. Randall just takes it sexist. I was like, I would help you to the best of my abilities, I guess.
I hate everyone here, except Paula.
What did I do?
Okay, I like Curtis, too.
But Amanda...
No. Anyway.
So,
James, we're the most hated beings here.
Given this conversation...
She likes me a little bit more.
I said we're the most hated beings here.
Given the direction of the conversation, and we've been talking about with feathers, do we have any sort of closing thoughts or any ideas we want to talk about for what this might potentially mean?
I think it comes down to, again, you need to, whenever you have this sort of discussion and this sort of field of research, you need to sit down and really get your homology statements as to what is actually directly developing from what. In order, and the polarity of these changes, like we talked about, the endothermy, ectothermy, whichever one of those is the original condition for birds will have great ramifications to whether things are independently evolving endothermy, or whether things occasionally just revert back to ectothermy, and it seems like a minor difference, but it can have big ramifications for what things are actually doing.
Yeah. And it certainly is interesting that as time goes on and we get more data and we get more information, new fossil finds, new interpretations, we can see how previous ideas for how these things are evolving might change or be modified.
Yeah.
And as I said, I think it really does also speak to a lot of evolution. Like so many people, like you go to the Michael Behes of the world that want to try and say that evolution is irreducibly complex because you can't get a perfect structure through natural selection. But what he's missing is that so much of evolution is the evolving a simple structure and co-opting it for something else.
The only reason we think of the things that are here now as perfect is because they're what we've got.
That's also true.
Yeah.
There is certainly a bit of looking back into the past and saying, oh, well, we have this all here, and so it absolutely has to be the best of all possible worlds because we can use it.
If we had anomalocarid still roaming around today, we'd be like, wow, that's the epitome of bleh.
I do always...
Coelacanth. That is the epitome of all fish.
I mean, if
coelacanth's still around, yeah, it totally is.
If all amphibians had gone extinct, which sadly it looks like because of that fungus they might be heading that way. If we'd never seen an amphibian, we'd just assume they were rubbish and couldn't cut it.
Yeah,
that's true. Yeah, we would invent this whole story about how the reptiles obviously outcompeted them because they were so much better.
Mm-hmm.
Yeah. Mm-hmm. Wait, we just got back to evolutionary fauna somehow.
Oh shit!
Oh, well.
This is.
Does that mean I have to talk about the Edmund Fitzgerald again?
Sure. We can close out on that.
James, your story this time.
James, what happened to the Edmund Fitzgerald?
There was a boat.
Yeah.
And
where was it?
In a lake.
In a lake. It's more like an inland sea, but yeah, keep going.
And
what lake?
They were Michigan.
No.
Yeah.
Let him continue.
What's the name of my college?
Lake Victoria.
Lake Victoria.
Yours is your Lake State.
I like James'
Lake
story
Superior
better.
State University.
Oh, okay.
Lake Victoria. Jesus Christ.
Victoria.
And the African Queen went out on the lake.
Okay. I like this.
And there was a storm.
When did the Nazis come in?
Well, when they looted the gold from the boat.
Obviously.
And so there was a
Pirate
storm.
gold, right?
Yeah, there was a storm and they lost someone else that they were following or they were ahead of or something.
Okay.
And then they lost radio contact because people don't know how to use radios and somebody also left the door open. Okay. And they sank within about 10 minutes. And then people made a beer out of them.
They did. And then Gordon Lightfoot made a career out of them.
Yeah, and then the Nazis sent divers and took the gold.
Okay. Yeah, that makes sense. Well, this has been Curt.
Randall.
Amanda.
Me.
And we're signing off. That was fun.
That was the best description of the Edmund Fitzgerald.